In this problem, we're given two equations, so we call this a systems of equations, meaning there's more than one, and we're looking to solve for the variables both x and y. So we have 7x plus 10y is equal to 36, and we have negative 2x plus y is equal to 9. So a strategy that would be really good here is substitution. However, we'll see that we don't have any of our equations in x is equal to something, right? Or y is equal to something. So in order to use substitution, we need to have x or y isolated. That way we can use that variable and substitute it into the other equation. So we need to manipulate one of the equations to get them in either x equals form or y equals form. So because here we have coefficients in front of the x and the y in the first equation, but in the second equation, we only have a coefficient in front of the 2x and nothing in front of the y other than an imaginary 1. We're going to use that second equation and manipulate it into y equals. So we're going to take our equation and manipulate it to get it into y equals form. So negative 2x plus y is equal to 9. So we're going to change this, and it makes the most sense to isolate y because remember, y is already alone. So I'm going to actually highlight y in red. So in order to get y alone, we're going to use inverse operations to move terms to the other side of the equal sign. So we're going to add 2x because the inverse of subtraction is addition, adding 2x on both sides, and we're left with y is equal to 2x plus 9. And we'll see here that we now just have y equals. So all we've done here is we've kind of changed this equation. So it's the same equation, but we've just rewritten it now to y equals 2x plus 9. So again, it's the same exact equation. We've just changed the way it looks. So I'm going to now think about my two equations that I have, my two systems, as 7x plus 10y is equal to 36 and y is equal to 2x plus 9. And the benefit of this now is that I can take my equation y equals and literally substitute it in for y. So you see we have y here is equal to 2x plus 9, and we can literally substitute it into this equation here for y. That way we only have x's left in the equation. So what we mean by that is if we take the 7x plus 10y is equal to 36, we can take that equation y equals 2x plus 9 and substitute in 2x plus 9 for y. So we're left with 7x plus 10 times 2x plus 9 is equal to 36. And now I'm just going to simplify my equation to solve for x. So before, in both of my equations, I had x's and y's, and now I combine my equations by substitution, and the only variables I have left in my equation are x's. So I'm going to draw my wall, and we're going to simplify the left side of the equal sign. So we're left with 7x, and we're going to distribute the 10 into both terms in our inside our parentheses. 10 times 2x leaves us with 20x. 10 times 9 is 90. That's equal to 36. And now on the left side of the equation, we're going to combine like terms. So 7x and 20x leaves us with 27x plus 90 is equal to 36. And now all like terms are combined on both sides of my equation, so we're going to use inverse operations and subtract 90 from both sides. And we're left with 27x is equal to, and 36 minus 90, we're left with negative 54. And now I'm going to use inverse operations as my final step. So the inverse of multiplication, 27 times x, is division. The 27's cancel out, and we're left with x is equal to negative 2. X is equal to negative 2. And now we have one variable x is equal to -2, and we're going to use this to solve for y. So we're going to want to go back to our two original equations and see which one it makes the most sense to use. So we could substitute x equals -2 into this first equation here, but we'll see that that's the most complicated equation to use because it's dealing with the most coefficients in front of the variables. So instead, we're going to want to use this second equation. We could use the one here, but again, we would have to manipulate it to get y equals, or we can just use this equation here where we already have y equals and we're going to substitute in for x. So again, you can use any of the equations. We can use the first one or the second one manipulated, right? So we can use the second one or the second one manipulated. But it seems like the second one manipulated is the most like advantageous, or the most the less complex, because we already have it in a form of y is equal to 2x plus 9. So we can substitute in our values for x here. So we'll see here that x is equal to -2, and we're going to substitute it in right here. So we're left with y is equal to 2 times -2 plus 9. So y is equal to -4 plus 9, and -4 plus 9 gives us 5. I'll use a different color. So we have both x and y. Now if I graphed both of these lines, and I saw where they intersected, the intersection point would be at -2, 5.